Now I'm hoping, using my iPad here, that I will be able to sort of do some animations that will help explain how to do these questions and where the angles are coming from. So this is basically the first example, and it talks about two forces acting on an object, and it gives the angle in between the two forces as being 35 degrees. Now, I've said more than once, even though a jet plane might be going east and north at the same time, we can sort of pretend it's going east and then north, or north and then east. And even though we have these two vectors that are acting on an object, let's say a tow truck, two tow trucks pulling a car at the same time, we can kind of pretend for mathematical purposes that it's one then the other. So as a result, what I'm going to do here, this is the diagram we start with in the first example. I'm going to take these things and I'm going to move them over here, because this is how we're supposed to draw vectors when we're working with them. It's one then the other, or tip then tail. So the resultant is this, and because we have this 35-degree angle in there, that tells us inside here we have 145 degrees, because they have to add up to 180 there. And now we have this side and this side and this angle, so we can find that side, which is the resultant. And I think hopefully you can see the calculation in the lesson. Now this one here is also, this is the second example. This is about the piñata. I will try to draw the piñata down there. Actually, I should probably just get rid of it. Now, so this is basically the diagram that we're given. And I guess this is pretty much the diagram. I want to point out, if this angle here is 32, then this angle down there is also 32. All right? And that's really, really important. Now I'm going to just erase that thing. Now, again, we have two forces acting on the object. Oops. Right there. However, it's better if we think of this as one then the other. So I'm going to try my best here to take this and move it up there, and this looks pretty good. Okay, now I'm going to erase, oops, didn't mean to do that. There we go. I'm going to erase that, don't need it. So basically the resultant here is that, because the piñata is pulling down, so the resultant of these two vectors has to be going up. You'll notice this 32 and 28 is where the 60 comes from. This side is 94. This side over here is 97.9. It's kind of hidden there. And law of cosines, again, will tell us the length of that side. The key here is the movement of the vector that was here, taking it and moving it up there like that. That was the key to that question. Now for this one, the car rolling down the ramp, or preferably not rolling down the ramp. So we have the mass of the car, and we multiply by 9.81 to get the force of the car going downward due to gravity, and that's right there. Okay, I'll rub that back out. Anyway, so that's the force, 19,620 newtons. And what we're doing, it becomes the hypotenuse of this triangle right here. And we're taking this hypotenuse and breaking it into its perpendicular components. Now, this one goes directly into the ramp. And as long as the ramp is strong enough, it pushes right back. So there's no effect on that. It doesn't really do anything. This force isn't that important. However, this force, the one parallel to the ramp, this is what's going to cause it to try to roll down the hill. Well, if it rolls down the hill, that's a bad thing. Anyway, it makes perfect sense. If this angle isn't very big, then this angle is also not very big, and that side would also not be very big. That makes perfect sense. If the angle isn't very big, we don't need a lot of force to hold the car from rolling down the hill. Anyway, I'm just going to erase some of these again. Perfect. So what I want that side. That is the opposite side. Now, if I called that, let's say I called it Vx. Actually, you know what? Let's call it F, because we're talking about forces here. If that's Fx, if it's the opposite side, then sine of 15 is the opposite side over the hypotenuse. But we've done this so often now that I will go straight to that side. The opposite side is the hypotenuse times the sine of the angle. And this is really a common question, as is the pinata question, as is this question. Again, this is, for example, two tow trucks pulling a car. But there is hopefully some help, some visuals to explain where I'm getting some of these numbers and how I'm drawing the diagrams.